All right, guys, welcome back. As you can see, we have the whole crew right here from Radix. Matthew, Jeremy, Pierce, big welcome to the show. In this video, we're going to discuss what Radix is, what kind of problems it solves, how it fits into L1 space, because there are many L1s, but still nothing has really competed with Ethereum in the ways that the marketing describes, so to speak. So let's see how you guys are planning to do it. So welcome everyone. So let's start with introductions. Pierce, let's start with you.
Sure. So my name is Piers Ridyard. I am the CEO of RDX Works, which is the core developer of the decentralized finance protocol Radix, which is public ledger entirely focused on decentralized finance. Now, my background, I got into crypto in about 2014, 2015. I was mining on the Genesis block of Ethereum. I got into crypto from that point of view, but got really excited about smart contracts. Ended up building a Y Combinator company, went through Y Combinator. And at the end of Y Combinator, was acquired by Radix and ended up becoming CEO of RDX Works.
Fantastic. Jeremy?
Yeah, sure. Hi, everyone. I'm Jeremy Epstein. I'm the Chief Marketing Officer here at RDX Works. I got my first Bitcoin back in 2013, but went all into the space in about 2016. Written a bunch of books on the intersection of crypto and marketing, given a bunch of speeches, worked with projects like Zcash and Dapper Labs and Arweave and a number of other top tier projects. And about 2 years ago, I came across Radix and I met the team, and I was like, oh my God, no one is thinking bigger than Radix about the potential for what DeFi can look like. And no one is thinking more broadly about what the solution is. And at the end of the day, man, it's all good if we want to go make money. There's no problem with that. But I'm in it to go out and really bring about the transformation of the economy from TradFi to DeFi, and the mission aligned with me and joined the team, and they haven't fired me yet.
Strong
That's
statement.
good.
Strong statement. Haven't fired me yet.
I'm optimistic, right? I'm hanging there.
Yeah. It's good bar. You're setting the bar.
By the time this airs, I might be gone. You never know.
Exactly.
And yeah, I'm Matthew Hine. I'm the Chief Product Officer at RDX Works. So my background is very much engineering. I've worked with sort of complex systems throughout my career. I worked at Texas Instruments for a while. I've always been kind of like gravitationally pulled towards really interesting technologies and figuring out how to do interesting things with those. So I had my mind blow moment in 2016 or so, started reading about blockchain and realized, holy shit, this is the thing I want to spend the rest of my career on. This is the best technology I'm likely to encounter in my lifetime. So it was only about like 2 months later when I quit my job, kind of struck out into the crypto wilderness, trying to find my place, and pretty quickly fell in with the Radix guys and realized, yep, these are the people that are thinking about the problem right way, and managed to worm my way in behind the scenes and get involved because that's where I wanted to be. So,
well, most people watching this, they know Ethereum, they know Solana. They have tried DeFi on Ethereum. So how did you approach this? You were also, I guess, using Ethereum, and what kind of problems did you see that nothing can solve on Ethereum? For example, layer 2s, the ZK rollups, optimistic rollups, all the different technologies. What did you see that was impossible to solve?
Yeah, I mean, it's a great question. Each of us answer in a completely different way. So I think, so what do you want? Do you want the really high level answer, or do you want the really sort of in the weeds technical answer?
Yeah, let's start with the high level, and then we can dig deeper.
Okay, Jeremy, do you want to go with the high level?
Yeah, sure. I mean, at the end of the day, the promise of DeFi is there's a $400 trillion global financial system out there, and today all of crypto is what, 250 billion. I mean, it's an ant on the back of an elephant. So what we decided, or what we said, is let's start with that question of, okay, if you were going to take this $400 trillion financial system and it was all going to sit on a decentralized financial ledger, what would you need to build? And then we worked backwards from that problem, which brings you to a very, very different conclusion than what everybody else in the space is doing, which is, hey, let's roll out a blockchain and let's iterate and start to fail our way forward and add some layer 2s, which breaks composability and increase gas costs and what have you. And we saw all these issues, and we said, look, this will never get the mainstream, the $400 trillion economy. It's just not going to work as much. And look, if you look at our background, there's a reason why we have these two types of lanes, right? We love Vitalik. We love what they've done. Ethereum is like the Wright brothers. They've invented flight. But that doesn't mean you solve the problem of how you get 350 people from New York to Frankfurt, right? And that's what we said, is we have a fundamentally different outlook. And we started from that premise, work backward, and we came up with a radically different approach to how you build a decentralized platform. So there's your marketing pitch, but if you really
and now is the time. Exactly. Now that that's over, let's go into the Well, I mean, to be fair, I think it is basically what everyone says. I mean, if we're fully fair, that's what Solana will say. That's what Avalanche will say. So let's go into the technicals.
Yeah. So before we go to Matt, because Matt will give a fantastic answer, I want to add some numbers here, right? Because if we're saying that we're decentralizing global finance, let's look at global finance, right? Global finance does between 2 and 20 million transactions per second across all of the markets, 2 and 20 million transactions per second. DeFi, if you do something on DeFi, one transaction on DeFi is not one transaction, right? If I swap on Uniswap, it creates a secondary arbitrage opportunity across another thing. It triggers some rebalancing on Balancer or something like that. So one transaction is actually like 5 transactions or 10 transactions. So if we wanted to just bring what is currently global finance today across to DeFi, you're looking between 20 to 200 million transactions per second. And Solana, the fastest in the space at the moment, is saying, well, 65,000 transactions will be enough for anyone, and we'll just grow from there on the basis of compute power. Like, it's not even the right ballpark. They're not even playing the same game, right? If you're actually looking at what global finance is. So that's the first thing I'd say in terms of like level setting. And the second thing is that if you went back to the start of the internet and you sat all of the smart people in the room and you said, hey, I'd like you to calculate what the bandwidth requirements of the internet is. We've just created this new thing called the internet. No one's using it. What kind of bandwidth are we going to need? And someone puts their hand up and says, hey, look, let's count all of the telephone calls and all of the fax messages that are happening right now. And that'll be approximately the bandwidth. Now, future back, looking at that, we're like, that's stupid. Like, that's not even close, right? So if we're saying global finance today is like 200 million transactions per second, and the future of that is the composable, fully decentralized infrastructure, we're probably not even close to 200 million transactions per second. So like layer 2 solutions and all this, it's not even thinking at the right level. So that's my level setting in the answer to, yes, they'd say that, but like really the numbers don't add up against what they're trying to do. Matt, I'll let you answer the other way.
Yeah, okay, I'll go all the way down. Yeah. So I mean, to me, like I'm an engineer and I'm allergic to hype. And so like to me, the important thing is does this marketing, like you said, everyone will say the same sort of marketing message in the space, but does this actually translate down to the engineering decisions you make? And I think one of the really important things is, does it translate to the assumptions and the priorities that you set when you're engineering a solution? There's something that we like saying, which is a great thing. I think it's something that our CTO came up with, which is that the crypto space is full of incredibly intelligent people. I mean, like you talk to, the engineers at all the top projects, and they are some of the smartest people because this technology draws some of the smartest people. But there is definitely like there's a notion of solving the right problem, and there's a notion of setting the right, like making the right assumptions so that you're engineering towards the goal you're trying to achieve. So everything Piers says about the real goal that we're trying to achieve has directly influenced our decisions. And actually, this goes even back before Ethereum. This is like, Dan, our founder, his original thinking about blockchain infrastructure and where this technology is going goes back to his reaction to Bitcoin and realizing Bitcoin is amazing, but it's not going to solve this huge range of problems. And so then Ethereum happened. And so we've had a lot of these incremental improvements over, Ethereum and other challenges that have come in since that point. But it's all been that sort of incremental improvement. The engineering goal has been like, all right, here's something that works. Let's now try to solve this one particular problem, put a bunch of really smart brains on solving that problem and make an incremental improvement. And then we'll launch a platform and start getting people coming in our platform. And we just came at it from a very different direction. We looked at this and good, look, it's a risk that we're taking by taking this approach, but we say, rather than taking a safe incremental approach like that, which is much easier to raise funding on, it's much easier to convince people of, we said, look, none of this matters unless we can solve this end state problem. And this end state problem is there needs to be a platform which can handle global level throughput, like Piers said. It's a platform that is buildable to the level that a world of developers is used to. Like, it needs to have the maturity of developer experience that you're actually going to be able to build multi-billion-dollar applications on this platform and have people rely on it. It needs to include even the user experience that's wrapped around this. It needs to be accessible to anybody that's going to be using the platform, not just people that are really into the tech and understand how MetaMask works. So this is driven all of our engineering decisions and all of our assumptions going back for something like 8 years. And now this stuff is starting to come to fruition. We've got our smart contract approach, which just came out about 9 months ago, called Scripto, and other stuff like this. Yeah, go please.
So let's get into how this works, because again, what we've been also hearing. I'm playing a bit devil's advocate, so this talk is interesting. But we've been hearing about this a lot. You know, Solana said the same. We don't want blockchain. We're completely different. It's not building on ETH. It's completely its own thing. And Radix is also coming. You guys are coming out with a similar approach as well, saying that this is completely different. Now even bigger than Solana. We need probably billions of transactions per second, like you say, if finance is gonna scale with this new innovation and new use cases like internet scale, the fax machines. So how does it work? Why doesn't Vitalik say, let's take it, the Radix tech? Let's take it. What is the tech? How would you?
That's exactly the right question. That's exactly the right question. Is like, why doesn't Ethereum absorb this and do things? Because, and it's a really good comparison against both Ethereum and Solana, because I think, again, both of them are, it's the problem you're trying to solve. So in our case, it's not just a problem of scalability alone. Like, I almost can't talk about that in isolation. I need to talk about it in the context of everything that we're doing, because what we need to do is solve the scalability problem at the same time that we're solving the developer experience problem, and at the same time we're solving a user experience problem. All of these things need to be solved at once. And the wonderful thing is that if you're willing to bite off that scale of problem, you're basically, what you're saying is, we are willing to redesign this entire stack, bottom to top to bottom. We are willing to throw out all past assumptions, all past compatibility. We're throwing the complete thing open. If you're willing to do that, it hugely opens up your available solution space. So for example, Solana is specifically trying to solve this problem with scalability. They say, all right, we've set this target. We think we can reach this TPS goal. But they're making the assumption built into that, sort of, we need to make a scalable network that is running smart contracts that are more or less as they've been formulated on Ethereum. They're using Rust, but fundamentally the virtual machine approach is the same as Ethereum. If we tried to do the same thing, if we took our scalability approach alone and we said, well, we're going to try to run EVM on Radix, it wouldn't work. We couldn't reach our scalability goals. We had to drive requirements into how the virtual machine works to reach the scalability. And likewise, we had to drive application level virtual machine requirements into the consensus level to make the developer's experience make sense. So this is the whole problem. And especially with Ethereum, you talk about why can't they do this? What you're talking about is they're victims of their own success. Because they're the incumbent, because they have billions of dollars of applications that are already on this platform. People have built businesses on top of this. Their livelihoods are dependent on Ethereum being stable. Ethereum essentially cannot implement any of these things because it would require re-architecting the entire stack, which would mean, you can see how difficult it is for Ethereum to move to just proof of stake. We're talking about not just that level, but the entire thing. It'll never happen.
You mentioned something interesting. So you mentioned the virtual machine that is, as I understand, it's more efficient because it's not a virtual machine, but it's something else. That it's you've done it better than Solana because you've taken this approach without virtual machine, correct? But that's not this bottleneck of scalability, because the virtual machines, they're fast as is. They're not slow. The bottleneck of scalability is often the consensus, and that you need to get everyone on the same page, and the thing needs to travel, and you cannot have forks, and everyone needs to sync and to minimize the risk of the fork. So do you agree with that? And if yes, how do you then solve the consensus bottleneck, which is the bottleneck in performance, right?
So I would say, like, just to grab that question, let's start with Scripto, and then go down to the Radix Engine, and then go down to consensus, because if we go the other way, it's going to get very confusing. So I would say let's start with Scripto, go to the Radix Engine, go to consensus, and then I promise at that point you'll understand how they all fit together and also how you achieve the scalability. But until those things are all together, it will feel very bitty and not completely sort of filled.
Yeah, and the other thing is, the question you ask is an important one. Scalability is a huge thing, but in our opinion, it isn't even the top problem to solve. Like right now, if you're talking about bottlenecks, what we're really talking about is, what is the bottleneck from where we are today to mainstream DeFi. And we've talked to developers across the DeFi space, and scalability is definitely a pain point, but it's not actually the main one. Developer experience is seriously a problem right now. Like, I mean, you can express this in different ways. You can express this by the tiny talent pool in Solidity today, or basically any smart contract language. Like, compared to the general developer world, there's a tiny number of crypto developers. That doesn't make any sense. Why is that? It's because the developer's experience is awful. And also you can express it in terms of, you know, basically wrecked, like, their feed of projects getting hacked. These aren't stupid people writing the smart contract. It's just not a good enough developer experience. So anyway, I want to give this context. But
yeah, I mean, you can fix any developer experience. Just look at the internet and HTML and JavaScript and CSS, like horrible developer. It's like 3 languages mashed into one. It's still the standard and the global. So I don't think that that's going to be like the decisive factor, because it's important, but developers love tools, you know, love making packages. It's just, we're making developer tools as well with APIs, and we just see every day there's some new, you know, package for this, package for that. So with time, I think developer experience in all platforms that have traction, they will be resolved, even if the fundamentals are bad. Just like with the internet, fundamentals are horrible with HTML, JavaScript.
Yeah, I mean, this is why we have to go layer by layer, because
right.
I'm going to debate has an impact on scalability and all the other stuff as well.
And I'm going to debate you on the premise on this, because I don't believe this is actually something where we can't use the same metaphor from the internet, where, well, there's the internet as a protocol layer, and then you have full freedom to define a developer experience on top of that. The fundamental difference is, when we're talking about DeFi or we're talking about Web3, we're talking about a platform that is designed primarily for asset management. And so that is a core platform feature. And once you make certain platform decisions, you cannot change anything at the language level. And this is what we mean by the EVM. It's not a matter of efficiency. It's the fact that it's specifically the Ethereum virtual machine approach to running smart contracts. Before you even get up to the Solidity layer, it's the idea that the way you create a token on Ethereum is via a smart contract. We think that's broken. This is a problem. And
so
the only
let's move to what Radix is doing.
And just to be another devil advocate, that's exactly what the Avalanche team told me as well, that they don't like that tokens are not native. It's just a program. It's a smart contract, and they want to make them native. So I've heard this. I've heard this theme as well. So it does make sense that basically, if anyone can make a token contract, you can manipulate however you want. One token can pretend to work in one way, and then another token can just change balances without events, which is a horrible developer experience. And you can have rebase tokens which don't do any events. You just wake up one day and you have totally different balance. There's no trace or anything. So I totally agree with. But I'm looking for this, you know, this new dimension that you guys are speaking about, this whole new world which takes us from the White Brothers to the Paris to New York flight.
Right, and this is what we're trying to get to. Is it's you got to hit everything. You got to solve scalability. You got to solve developer experience and these things. So let me give you the little stack rundown here. I'll try to do this as briefly as I can to give you kind of like what's different, because like it's definitely what we're doing is not the same as the Avalanche approach. It's not the same as the Solana approach. So starting at the top level, you know, the most visible thing is crypto. We have our own smart contract language. In some ways, that's kind of the least important thing to me. Like we decided to base it on Rust. That's fine. That was kind of an incidental choice. Basically, the way to think about it is that a language is just running on a computer. This is in any circumstance. And the computer that a smart contract runs on is the virtual machine of the network. So on Ethereum, it's the EVM. Other networks have variations, but basically the computational model that they follow is virtually identical to the Ethereum model. You know, it's all sort of incidental implementation. Basically, it's the same style of computation where you have programs that run in this network. They can talk to each other. That's the extent of it. This is the feature set. From our point of view, so our virtual machine, we call it the Radix Engine, and the primary difference between Radix Engine and every other virtual machine on every platform is the fact that it introduces resources as a platform level concept. So if you think of this as the computational environment, this is the big world computer that everyone's smart contracts are running on. Ours natively understands the idea of assets via something we call resources. And it's not as if we have an ERC 2020 contract that's running on the platform. It's literally the fact that like the platform understands the idea of a resource as a physical thing that moves from place to place and obeys the kinds of rules that we're used to for assets in the real world. If I'm holding something, no one else is holding it. If I give it to you, I give up control of it. There are rules associated with who can hold what at any given time. So we kind of like, there was actually someone in our developer community that made this analogy this morning, which I thought was awesome, was that the Radix Engine approach is it's like physics. We're discovering the universal rules of assets. It's not as if we're sort of imposing, we're saying, okay, you shall develop tokens in this particular way. We're finding what is the universal concept of assets that crosses everything, and we build those rules into our virtual machine. When you build those into the virtual machine, now the language has access to a lot of really powerful stuff. So Scripto is based on Rust, but if you compare Solana code, which is also based on Rust, to Scripto code, the results look completely different. The smart contracts look nothing alike, because ours are speaking in terms of assets. When you're talking about moving an asset from place to place, you're literally just saying take, put. You're manipulating those assets in the way that you would a physical asset in the real world.
Right.
So we have to do that at the virtual machine level. And then, there could be different languages, there could be different tools that get built on top of that, but you have to do that part of it at the protocol level. You can't innovate that after.
And that is developed, and I totally agree with that. So that's amazing, because then all apps know how assets behave. You cannot create an asset where you can change owners without actually having a change ownership event. That makes perfect sense, and that's like a plus in developer experience. So just so we're clear, because it's not a plus in scalability. It's not a plus in
not yet. I haven't gotten to the scalability part of it.
Right. But so just so that we're recapping what we've said. I think what you said is amazing, and this gives us DX, developer experience.
Yeah.
Right, and also user experience. Like, imagine, I'll give you one example that people love, which is if we found out that actually a lot of people don't even know this in the crypto world. Like, what is an account on Ethereum or any other platform? An account is basically a key pair. It's an address that I own, and I can use my key pair to control that account. And if I want to get my balance of tokens in my wallet, what the wallet is actually doing is it's going out and querying all these independent smart contracts and going, hey, for this address, what's the balance? What's the balance? What's the balance? So it's kind of like talking to 5 different banks or 20 different banks and going, hey, what's my balance here? And then you sort of show that in a combined wallet view.
It's impossible. You have to use, you have to index it. It's horrible. I agree. You have to use an API. And that's why we start Moralis, because look, the wallet does not know my NFTs. If I'm building a dapp, I was thinking, you start in blockchain development, you think it's all on the blockchain. You just, here's the wallet, give me all the assets.
Right.
No, it doesn't know. Right. And that's why in MetaMask, you have to add assets, because it has no clue which assets you have. So yeah, I fully agree on that as well, that it solves developer experience and user experience for sure. Yes.
Right. So one of the cool implications of having resources as a platform level thing is that our accounts are actually an on-ledger thing. Like, when you have an account and you have a wallet on the Radix network, there is literally this thing called an account component on the network, and that thing holds something we call vaults, and vaults contain resources. So when my wallet is looking at my balance, all it does is it goes to my account and says, hey, what's the current state of my account? And it goes, well, here are all the resources that are contained in your account. It works exactly like you intuitive thought it worked, but it actually didn't. So like, when you have that sort of intuitive thing, it makes everything easier. It means that wallets can be more communicative. They can tell users what exactly they're holding much more clearly. It solves a lot of problems with transparency and exploits that we get today. So anyway, you get that part of it. Let's go down to the next level, right? Okay. So translating that level, that virtual machine, down into ledger state means you need to kind of break up that state. Like, how are we representing all this on the ledger, and how are we doing transactions? Because our transaction model also has to be completely different here. We can't do the Ethereum style thing, which, by the way, is a problem on its own. On Ethereum, or pretty much any network, every transaction is, here, I'm calling a method on this smart contract. Here's the data I'm passing it. I sign a hash of that and I submit it to the network. The user has very little clarity about what's actually happening there. The cool thing about us is that our transactions can actually describe asset flows. So in our case, if I'm doing a send of a token, the transaction, we have something called the transaction manifest, which basically says, line by line says, I'm pulling these tokens out of my account. I am depositing those tokens in someone else's account, in those sorts of terms. DeFi interactions, like a Uniswap, is the same sort of thing. I remove some tokens from my account, I put those into the swapping component, it does a little bit of logic, and it gives me some tokens back. You get this it's highly composable, and I could go on about that. But the important thing is the ability to do this, to be able to very clearly describe in the transaction what we want to happen and what things it's going to interact with gives us a superpower down at the consensus level. Because what it allows us to do is every single transaction describes exactly what its dependencies are. It describes, what do I need? What is relevant for this particular transaction to happen? For this transaction, these 2 accounts and these 3 DeFi components and these tokens are relevant. And nothing else that's happening on the network is relevant at that time. And so we've built our consensus mechanism called Cerberus around that assumption. Basically, if you read a Cerberus white paper, it starts with some assumptions. It says, given an application layer that is able to specify those kinds of dependencies, we can then structure the entire consensus design around that. We can say, well, we can now separate things that are unrelated, gather together things that are related, and only do consensus around those related things. And long story short, what that gives us is it gives us the ability to have unlimited parallelism. It means that the million things that are happening on a global financial network that are not related to each other can be processed completely in parallel. They don't interfere with each other. Whereas Ethereum and every other network, there is a certain amount of sort of required global serialization that you just can't get away from, because the virtual machine is designed around that assumption. It's designed around the assumption that, well, anything that gets submitted is a smart contract call that must be serialized globally across the entire network. We break that assumption, and now all of a sudden we can come up with a consensus design that no one else can do.
Yeah, so that's very, yeah, that makes sense. That makes. I'm trying to think if because you can have many things in a block, right? So you can have many things kind of in parallel, it's just that they're all like processed at the same time. They're like confirmed at the same time. But here you mean that if I'm
bottleneck is consensus.
With, yeah, right. The fact that they all need to be confirmed in batches, and then everyone needs to guess the batch, and we cannot start the new batch.
And inside the block, every transaction is still ordered versus each other. You have essentially a list of transactions that are in order. Whereas if you essentially have multi-threading of consensus, where every consensus operation that is dependent has to be ordered, but everything that is not dependent can start and end at any point versus any other. Right. You now break huge amounts of bottlenecks in how blockchain works today.
Right. It's kind of, we've been toying with the idea of talking about threading is a good way of thinking about this, because if we have the shared computation environment, we have a sharded design, but we almost hate to say sharded because immediately people make all these assumptions about what sort of sharding you have and how it works, which is generally not true for the way we're doing it. It's not just like sharding is basically a database term. For us, it's really processing. It's the idea that you are multi-threading your overall, your global computer, so that you only need to come to agreement on things that are actually related to each other, because the ordering between me paying for a coffee and someone else. Sorry, go ahead.
So different computers in the network then can verify different threads, or they don't have to verify everything that happens. It can be divided. Some of them verify some things, and
right. To get very tangible about what it means is that we can have essentially an unlimited number of people that are running nodes on our network, and the protocol will automatically. We have this pre-sharding concept, which gets into details, but basically automatically everything that's happened on the networks gets distributed across this huge range of computers. And each one of those computers is servicing at any given time a very small amount of the responsibility for everything that needs to be processed. So this group of computers can come to agreement about this and go, yep, this is abiding by the protocol, and we've got stake backing and all that kind of stuff. We commit that. And it can do that completely in parallel to something else. And what this means is that as the network experiences more demand, as we have more people wanting to do more transactions, what this means is that ultimately this should create more of an economic incentive. It's basically more people are willing to pay to get their thing processed. And as long as we have a consensus design that then encourages economically more people to join the network, now we've got what we call linear scalability, which means that the more nodes we add, the more throughput the network has. So when we say unlimited throughput, this is what we mean. It's the idea that more demand will automatically incentivize addition of more capacity, which is basically the way the internet is architected. It's the idea that if there's more demand, there's more pipe that gets built. We need that, or else we don't have a solution.
And how do I get the state? Because in Ethereum, any node has full state. They're synced to the block. This sequential processing is very simple in that manner that there is always the full state, whoever you ask. And here, everything is in parallel, just like my server. It has no clue about the entire internet. No one has any clue about the entire internet, with the analogy you said. So how do they know the state, how much money this contract has, or that, or wallet has? How does that work?
Oh, okay. When if you just want to I just want to make a query about, what's in this smart contract or whatever. Yeah. So there's a second layer to that. So the consensus layer is occupied with making sure that correctness is observed, making sure that anything that is committed is okay. It follows protocol.
Yeah.
Then as a secondary layer, we can how do I put it? We can index that state independently from consensus. It's not part of consensus. So basically, for example, if I'm running an application and I really care about this particular set of accounts and smart contracts, well, I can run a special kind of node, which then observes all of that state. Basically, I kind of put out feelers in the network and say like, hey, this is the state that I care about. I'm not taking consensus about it, but please, I want to know about this state.
Like
and
Google.
I will get the
threads are the
like
internet,
Google.
and then you have like a search engine on top here.
Right. So I definitely expect that, a fully mature Radix is going to have like the Google of DLT. You're going to have this master service that's indexing everything that will serve requests. And then there are also going to be smaller forms of this. There'll be like application specific things. You're like, all right, I'm really paying attention to this state. Or even a wallet, for example. A wallet alone is going to be so, look, I really care about the state of my accounts and I need to know about any updates to those accounts. So there's a lot of flexibility in how you do this indexing.
Let's say I have a wallet, you have a wallet, and we somehow have been completely separate. We don't share any node that has been processing our transactions together. So if I just want to know how much money you have, I need to index it, right? And let's say I don't find anyone that can index your wallet. Is that how it works? That basically my wallet needs to index your wallet, or
no? I mean, that case it would go to the Google that we're talking about basically here. Like now a wallet or a dashboard or a client or whatever kind of application.
There is some kind of indexer which is by default, that we should know everyone's balances, for example, of all tokens.
I mean, think of it, it's kind of like Infura on Ethereum. Like Infura is a service that provides this gateway into the network. And literally we call it a gateway. We have something called a gateway, which is, this is even running on the current network, but it expands with our sharded network.
But is that hosted by companies, or is that some more on like protocol level, that these gateways, they are part of some kind of protocol as well? Or it's
not protocol level. Yeah, it's business driven. And I think there's a natural thing here. Like basically offering that sort of indexing data is a business opportunity for people that want to say like, look, I'm going to build a gateway that's going to do really well at serving this type of application. You can pay me for this, or I want to run my own gateway. Spinning up a gateway is not complicated. So it's like, it might be my application has its own gateway.
Right. But let's say something very simple, just knowing everyone's balances, just to have a simple block explorer. What kind of resource do I need to have in order to do that? For example, on Solana, like to run a full node, it's a lot. Maybe you don't need a full node for that. But let's say on Radix, I want to index everyone's balances. Do I need a massive machine on AWS or small on my computer? I can do.
You need the equivalent of the bandwidth of the network and the storage requirement of the network at that point, right? So all you're doing is you're listening to what's happening on the network. So if the network is processing 1,000 transactions per second or 1,000 smart contract interactions per second, you need something that can take data at that rate and store it at that rate.
And I need to catch up and like index everything from scratch. So, but it's fair. Look, it is how it is. It's the same with Binance Chain. It takes like 3 months to index it full archive. It's the same. I mean, it is what it is. But I understand. Okay, that makes sense. That you have all of these threads, and you have basically a more bare bones solution, which is Radix. The bare bones is that it's a bunch of it's low level. It's low level in terms that it's very efficient. It's threads, parallel, but to use it, then you need an indexer on top, and so anyone can run it. It's kind of the graph on ETH that you can basically say, okay, I'm interested in this and this and this, and you can create your own indexer. I think
we made that very easy as well. The gateway service already supports that functionality. So if you want to go, I care about this. I mean, obviously, right now there's not much data, so you could just run a full node and get all of the information. But like you can with the gateway, you can already say, I only care about these events and these balances, and just deliver that to me. And the gateway service itself is designed around this concept of horizontally scaling architecture from the point of view of a query layer. That's the other thing that's kind of crazy about networks today is if you want to build a block explorer, you have to build a full node. And generally speaking, if you want to expand that out, you have to do load more full nodes. Whereas what we've done is we've separated out the concept of full node from gateway. So you can have a single source for the information, but the gateway service, you can scale out many, many nodes to deal with thousands or millions of queries if you're doing a DEX or something like that.
Data indexing isn't a blockchain specific problem. This is traditional world stuff. So this is a solved problem. So all we got to do is translate. We need to offer the data and then have a second layer, which is doing all the standard tricks from the traditional world.
What stops me from taking the software and just ignoring the consensus rules? And then people start indexing my information, which is wrong. In Ethereum and in Bitcoin, I would be mining without getting any reward, trying to sneak in false transactions. I would never succeed. On ETH, I will even lose my stake soon. But in Radix, how do you protect with people feeding the indexers bad data and ignoring the rules?
Yeah, well, you're not feeding the indexers. So the indexers are just keeping track of what data has been committed through consensus. So anything it's looking at is.
Yeah, but we need to connect to all of these different nodes, right? All of these different computers that are processing different parts of this state of this global network, right? So what if I have such a computer that processes transactions and I don't comply with the rules? I move assets back and forth without checking the balances. So how
the difference
do you
is you can't
prevent me?
Yeah, you can't conduct transactions on your own. If you want to do current transactions, you're participating in consensus. So kind of think of it as a read-write thing. So if you imagine if we have our global computer and we have transactions, we have input to that computer. Hey, here's a transaction that I would like to submit. There are rules associated with what gets written to disk, and this is where we get there. This is a multi-threaded rule set.
I think
I can tell them, okay, write it. I can change the code. People will send me the different peers in the network will send me data, and they will trust me to like you say to verify it correctly according to the rules. But I can just not do that, right?
So are you saying that how do you trust the indexer?
No. I'm saying what kind of punishment or some kind of exclusion mechanism there is on this core level, with like threaded level, against
the consensus, right.
Consensus, exactly, on the consensus layer, against people not following the consensus. Basically, how do I? How does the network keep me from messing everything up by just, I try to get a transaction into the state which doesn't make sense. Like I have $1 million, I pay you $1 million, I don't have it. I don't have that many coins. But I can say that, okay, here's a transaction. But how does that work?
Yeah, okay. So this gets into core consensus design. So we use if you kind of talk about the general classes of consensus design, there's kind of two worlds. There's what I would call Nakamoto style consensus, and then there's BFT style consensus. And if you look at the various blockchains that are out there, both of them, pretty much everything falls into one camp or the other. Avalanche is a little bit weird. It's kind of a third category.
Right.
So obviously Bitcoin and Ethereum use a Nakamoto style thing, which is essentially it's probabilistic consensus. It's all driven by mining, essentially. It's driven by the longest chain rule defines what is correct and not.
Yeah, I mean, the
very high
biggest
level
thing there is that if you want to propose something to the blockchain, you have to spend money. You have to either mine it, and then it's in your best interest that you don't cheat, because if you cheat, you mined in vain. No one's going to accept your block. And in proof of stake, you're going to lose your stake if you try to cheat. So there is like exclusion by your resource. You're going to get your resources taken away from you. So
so that's what I'm saying. So in the BFT style consensus world, it works a bit different. In that case, you're not following a longest chain rule. There are very clear protocol rules of saying, once you have reached this level of voting consensus between the nodes on the network, this is final. It is considered final. And so, and you get proof of this. Like you get cryptographic proof that this was in fact voted on by sufficient nodes that committed to the ledger and so forth like that. If you try to pretend, if you try to say like, oh yeah, the network totally approved this, it's a real transaction, you don't have the proof because you didn't actually go through consensus. And
well,
so
what if I create a million,
this makes it very clear.
I go to AWS, I create a million machines that all say yes, and we will. How do you protect against that? Like a Sybil attack.
Proof of stake. It is proof of stake. If you lie in consensus, you get slashed.
Right. If you lie, yeah, exactly.
Oh, so you have to stake, right? You have to stake.
Right.
Okay, then I get it. Then I get it.
Yeah, this gets to the like so nodes on the network are all backed by amount. In some way, like the basis of this is kind of like Solana or like Cosmos. The idea that you have a collection of nodes, there are tokens that are staked to those nodes, and the consensus mechanism basically decides what node is able to propose transactions at a given time. And if you do the wrong thing, yeah, you get punished.
Right. Yeah,
and
yeah,
that punishment comes via your stake. Yeah. Sorry.
I understand.
Much quicker answer.
Yeah. Makes sense. But yeah, all in all, I think we went through the entire stack. So let me summarize. So basically, we discussed
one more quick thing, Ivan.
Yeah.
Just one more quick thing that we've missed that is I think is really interesting, and I think we need to capture, right? Scalability. We're talking about scalability and why the execution environment plus the transaction engine plus Cerberus equals more scalability than other ledgers. So just a couple of quick numbers here. If you benchmark what we actually care about in DeFi, we care about DeFi transactions. What everyone is benchmarking against right now is transactions per second, which is crap. It's not even close to what we're talking about. We're talking about smart contract operations, right? So if you look at the Electric Capital report, Solana's throughput headline, 65,000 transactions per second. DEX swaps per second, number of times you can swap between tokens, 278. Right? Less than 0.5% of headline performance at smart contract level. Avalanche, 4,500 transactions per second headline. DEX swaps per second sustained, 32. Right? Polygon, 10,000. DEX swaps per second, something like 48. Right? So if you make resources native to the ledger as state transitions, now a swap is basically a very, very simple state transition because it's just I'm swapping this token for this token. Those are resources. So now you're suddenly able to get massively more performance, much closer to your headline performance than you are for the things that we care about, which is assets moving and smart contracts. And that's how the other way that we get close to proper through.
Makes sense.
Yeah,
I wish we could share screens because I'd show him this visual.
Yeah, but listen, I mean, we don't have to convince anyone here. I understand fully. It's the fact that you have these swaps being programs and it's a bunch of transactions in Ethereum to do a swap. It makes sense. And here you can have it native. It's like one operation. It's basically this what it's called, like risk versus something else in processor. You can have a simple processor with a bunch of software on top, or you can have more complex ones. So you have more stuff basically on the processor level that you can, it's like a swap you can do, and it makes
every
sense.
one of our transactions is a DeFi transaction. We have no special smart contract transactions. It's all even just sending you money is just interacting with contract logic.
There's one thing you should ask about, Ivan, and if you don't want to talk about now, we talk about time. It's atomic composability. Right?
Okay,
that's the part we didn't even discuss.
You want to talk about that for an hour?
About this. We could talk about it, but the point is, everybody else with their scalability approach breaks the superpower of atomic composability. Everybody else breaks it one way or another. What you have, and this is where over time, the exponential growth comes in because every single piece of code is automatically reusable by anybody else on the network. We won't even get into developer royalties later, but the point is, atomic composability doesn't break. And if you really want to send this thing to the moon, not the token, the whole concept, right? It's about atomic composability. That's what developers love, and that's what everybody else breaks.
But on that, let's say I have a contract, and you say it's composability and all of that, and I have another contract as a dependency. Let's say that there is another one, it's a dependency, but there is no common state. There's no common. I need to index stuff, right? In order to know what the other contract is doing, what the state is. So how will that work with this composability?
I'm glad you asked, Ivan. This is a softball. Yeah. So this is the magic of the transaction manifest. Is the idea that our transaction. So let's say if you got two components,
it's not a softball. It's hardcore. In your face interrogation.
That's true. That's true. It's a hardball question, but it's right up the center, so I can knock
exactly.
So basically, our if you want to have, let's make it even more difficult. Let's say we got three different things that you want to interact. You want to do something where I want to take a flash loan here, then I want to do a swap with it, then I want to do something else, and then I want to return that over here. So in our case, you can actually do that. You do that at the transaction level if you want to. Like the transaction can literally describe, call this thing, get these resources back, put those resources into the other thing, do this other thing, take that result, put it in here, get the result back, put the balance at the end in your own account. If all of that can be done correctly, the transaction is good. If anything in there is invalid, the whole thing is rejected. That's atomic composability, and we can do it at the transaction level. And to get to your to the question about multi-threading, is that when the transaction can describes those things, the transaction contains, hey, I need components A, B, C. I'm going to doing this resource. Here's what's going to happen.
Right.
The consensus layer immediately goes, okay, I know where to find those things. Those things are on shard, this shard, this shard, this shard, this shard. And it then means you have to then notify all those shards and say, hey guys, you're going to have to be part of this consensus round because you're related to this transaction. You're important here. And so those particular nodes will communicate for that transaction, come to agreement. They
have the latest state of the contracts.
Right, because they have to. They have to, right.
To create the transaction in the first place, you already have to have done the indexing. You have to have got the latest state, created the transaction, submitted it. And it's only the network is only dealing with validating whether or not what has been submitted is valid. There's no indexing required at consensus level. What you're submitting has to be valid.
Right. So the network needs to make sure that you're not double spending tokens, all that kind of stuff. It has that state available, and smart contract code can just be shared. It's just like, here's the latest state of the smart contract. Here it is. Cool. I run it.
Got it. So basically, if I have a wallet, and if my wallet is to do anything for me, it needs to be connected to some kind of indexer, right? That has all of the latest state, because otherwise it cannot say, interact with this contract or that contract. But if I have a wallet allows me to do anything, it needs to be connected to something that has indexed everything, right? Because otherwise it doesn't know the state, right? Or how does that work?
No, the point. This is one of the important points of the transaction manifest. Is it's unlike Bitcoin. Bitcoin, your wallet does actually need to know latest state because it has this idea of UTXO. Cardano also sort of famously made this choice where they needed the client to basically say, these UTXOs, or they call them EUTXOs, they're a little bit more interesting. They basically say, this is the state that I'm going to be using in this transaction. And it was sort of kind of headed in the same direction that we go, but the problem that they ran into is the first time they deployed a DEX on Cardano, this created a huge problem because you had multiple people trying to grab the same piece of state at the same time, creating a conflict. So now you had like 1% of the transactions would actually go through and everything else was getting rejected. And it was a huge sort of, fiasco for them. So in our case, our transactions describe intent. And this is a really important thing for two reasons. One, intent means that the network can make those decisions. The user says, look, I get to describe what I care about happening. What I care about is I want to pull 5 tokens out of my account and I want to put it in this thing and I want to get a result back. That's in the transaction. That's what I'm signing. The network then takes that and goes, well, based on current state, I can see that you have 5 tokens in your account. I'm going to take some of those tokens and I'm going to do this transaction with it. If you don't have those 5 tokens, then the whole thing is rejected. But the client didn't have to know anything about that. The client could just be completely oblivious about network state and just say, this is what I want.
Got it. So if I have let's say I have a wallet and I want to do some arbitrage. I have these 5 different marketplaces. They have different price for the same asset. And I tell it, go buy here, sell there, do some lending, flash loan, all of this massive chain. My wallet doesn't know the state of those contracts because it hasn't indexed that. I cannot have a full indexer in my browser. It either needs to connect to some indexer, but
it doesn't have to know. This is the cool thing. This is what's so awesome about it, is it doesn't have to know.
But if it doesn't know, then it cannot tell me whether the transaction makes sense, right? It will not tell me, okay, it makes sense. It's just that I do transaction, I publish it, and then it fails because. But for me to use such a wallet, for it to be useful, for usability, then it makes sense, right? To connect some indexer that can tell me that what you're trying to do here doesn't make sense, right?
Right. What the indexer will do is when you first get the transaction manifest in your wallet, so some DApp says, hey, here's a transaction that you might want to submit. The indexer, what it does is it will give you a transaction preview. So it can tell the wallet, hey, if you were to run this transaction right now, this is what you should expect would happen. Like the result of this thing is you're going to get back some 5 tokens at the end of this sort of thing. And the wallet user goes, oh, that's interesting. But there's an interesting point here that I also want to make is that the transaction manifest, like I said, intent-based. So what I describe in the transaction is what I want to have happen. This can include something called an assert. If you're a programmer, you know what an assert is. But basically, it's a statement you can put in there that says, I am making the assertion that this thing is true at this point. And if it's not true, we fail. So, for example, let's say I did this big complex transaction. At the end of that transaction, the preview says you're going to get back 100 tokens. But that's just an estimate. It might be that when I actually run the transaction, maybe something happened and I'm only going to get back 50 tokens. But what I can do is I can put an assert in that transaction that says, we call it a guardrail, basically. You put an assert here that says, when you get to this point in the transaction, there must be at least 100 tokens here to give back to me. If there aren't, the whole transaction's off. So this provides a wallet with an enormous amount of control to protect the user, to tell the user, look, I can tell you exactly what's going to happen here. And if for some reason this isn't valid, the whole transaction fails, nothing lost. You're not taking the risk. You're not assuming that this transaction is going to give me back a result because it looks like it will right now. It's guaranteed that the network will reject it if you don't get that back. And this is something that we think is really necessary for DeFi to go mainstream, because people aren't going to accept the idea that's like, well, I'm just going to trust this smart contract is going to give me back what the web page says. It needs to be in the thing they're actually signing and submitting.
Yeah, makes sense. I think it makes sense. So to summarize the stack, you have the language, which is, let's see, S crypto, right? That is based on Rust. Then you have the resources as a native thing of the protocol for developer experience, user experience. So you know that an asset is an asset, and you cannot have weird behavior. And also it's efficient because one transaction is one transaction, whether it's swap or something more complex, instead of being main transactions. Then we discussed this whole thing with threads and consensus, and how it works with staking and so on and so forth, and how indexing works. I think that's very, very interesting, and I've never heard anything like this. Is there something like this? Did you get inspired by something, or it's
this is what
research?
this is what happens when you start with a really ambitious set of assumptions and work on it for 8 years.
Right. Do you have peer review like Cardano? Many peer reviews?
Do we have peer review? Do we have papers out? Yeah.
Okay. But
all the papers.
I mean, there is this trilemma that someone has come up with, that you need to have decentralization, scalability, and security. You can only choose two. So how do you come around it? Is it like do you know if that's even like a proven computer science statement that you can only have two of them? Because I don't know if that is, but
it's not.
If it is, then how do you go?
Yeah,
about
the trilemma is a rule of thumb. It's an interesting rule of thumb, to be sure, but it's not like the incompleteness theorem, or there's actually a really important one in consensus theory that I'm not recalling right now, that basically says, there's one that basically says you can only guarantee liveness or security at once. You can't get both at the same time. So those are like proven consensus. These are
FOP impossibility.
FOP. Thank you. Exactly. That's what I was looking for. So those sorts of things are inviolable. But the trilemma is a rule of thumb, and basically, like it's to me, like, this gets into systems engineering. I love this stuff. I always think of these kinds of things as balloons. So you've got a trade-off balloon. You basically say, like, well, if I'm trying to build a system of this type, I can poke the balloon in one place, but it's going to stick out someplace else. You can't, it's easy to make those trade-offs. It's easy to poke the balloon in different directions. It's really hard to shrink the balloon. But it's not impossible. It's a rule of thumb. It's not a hard law. So all the trade-offs are possible, basically. But shrinking the balloon means you have to change the nature of the problem. And this is the whole point, is that if you're basically starting with, well, okay, we're optimizing Nakamoto consensus, or we're using the same virtual machine, you've got the same balloon. And so you can poke it a bunch of different ways, but you're not going to shrink the balloon. The whole thing about starting from a different set of assumptions and being able to design the thing from the top to bottom is the fact that we actually can shrink the entire balloon. Which means that, if you want to call that solving the trilemma, I think that's fine to say. It's not, I don't think it's something you solve, but it's a matter of what you need to get to is the relevant, good enough level on all three of these things that it can be the basis of a global financial system. And that means a much smaller balloon than is possible today.
You can say smaller. Why did you say smaller instead of bigger? In my mind, we're like blowing
well,
up.
You could say stretching the balloon. You could say you can pull on the balloon in different directions. Fine. Yeah. We want to make the whole balloon bigger. That does sound more exciting. Fine.
Right. Well, yeah, I think.
By the way, we tend to talk about the quadrilemma also. This is something you'll see. I think is because we think one thing that the trilemma leaves out is atomic composability, because this is also yet another engineering trade-off. You can get high scalability by compromising atomic composability really quick. You can pull that balloon in one direction and get a lot of benefit in the other direction. But if you're trying to pull them both, you have to have a different approach.
Makes sense. So this I'm still wrapping my hand around how these threads work. Can you compare it to gossiping protocols in some way, where it's also very it's not, yeah, I don't know if it's not really comparable, but yeah. How can we end this?
This is why you made fun of me at the beginning for the propeller and the jet. And what I'm telling you, my friend, is it's the difference between propellers and jets. And it is hard to get it. I mean, now you understand the CMO's problem here, because it is
exactly
different for guys like you and us who've all been in the space for so long.
Exactly.
Blockchain, like, you don't know what you remember that first moment you had that epiphany where you finally got blockchain. You were like, holy shit.
Right.
And all of a sudden you're like, well, this is radically different than centralization. There's a similar moment where you're like, okay, there's more than one way to do this. Just because, like, the first invention was the blockchain with the Merkle trees and all that kind of stuff doesn't mean that's like the entire necessarily path forward. Just because propellers with way of flight doesn't mean that's what we use, right? And it's hard, especially now. But if you look at the history of innovation, there are always these, quantum leaps or these radical leaps. And, like, yes, is it bold for us to say that? Of course. But as you dig into it, you're like, oh crap, this is a very different approach, because we started with
one thing, guys. So we've been speaking about this transaction, and that it can either fail or succeed, but that depends on the state, right? And who knows what is the state? Is it the longest state? Is it, what if some nodes, they think that this is the state because they haven't caught up yet? There's some guy in the other part of the world on some bad connection. He still doesn't have the full state. So in his mind, this transaction is correct. In some other people's mind, that transaction is not correct. So I'm trying to grasp my head around this. Threads, they're all independent. They have different states. So how does that work? Can it be that different transactions are correct at the same time, because nodes processing them have different state?
Right, exactly. And so there's two parts of it. One thing, as I said before, each transaction specifies these are the shards that need to be involved in processing this transaction, because those shards are the ones that have the state that is required to correctly make a decision about that transaction. The other part of it is, like you're saying, like, well, what happens if one node is behind? Well, if one node is behind, they're Byzantine at that point, basically. This is how Byzantine fault-tolerant consensus works, is the idea that if the node is really behind and it decides to try to participate in consensus anyway, which is a bad idea, a validator node should be caught up before it starts voting. But if it did try to do that, all of the other nodes that see that state are going to go, yeah, you're voting based on old state, man, you're wrong. And so they get voted out.
And so, who is that? Who is that? Is it randomly selected? Who is verifying who?
So it's the set of validators that are assigned to that particular shard for that transaction.
All right. So basically, a transaction happens, and a few validators, they need to validate it, and they basically vote. This is correct. This is correct. And then one person says it's incorrect. Then their vote is wrong. They lose their stake.
Yeah, well, not necessarily lose their stake immediately. There's more subtlety to it. But in concept, they're considered wrong. Yeah, and again, every one of those validators is supported by proof of stake. So proof of stake is the Sybil mechanism. It isn't just random people running. It's like you have to have a substantial amount of stake behind your node, which defines your voting weight, basically. So we have the same sort of guarantees whereby this protocol is safe as long as a third of the nodes aren't Byzantine and all those sorts of things. So by stake.
Makes sense. Yeah, perfect, guys. I think I grasp it, and well explained from you. Sometimes you interview people, they cannot even explain their thing. I'm like asking stuff they cannot explain, but you guys could explain it very, very well and simply. So thanks for that.
Very welcome.
Thank you.
And all in all, let's see how can people get involved? If I'm a developer, let's say, which is maybe the most important audience, how can I start coding something?
Okay, so if you go to good starting place is developers.radixdlt.com. You'll find all of the relevant links there. We've got documentation on Scripto. We've got a bunch of example code that our community has already been producing. They've been basically rebuilding DeFi applications in Scripto, so you can take a look at what they've been doing. You'll also find links to our developer Discord. This is a really great place to go. We've got multiple Scripto channels, all the way from, yep, I'm a hardcore developer, I've been working with Rust for 15 years, and I want to ask really advanced questions, all the way down to, hey, this is my first time programming, I'd like to start with Scripto. We literally have had people that have just started programming with Scripto, which is kind of remarkable to me. And in fact, there's a new sort of beginner cohort that's been going where they've been helping each other learn Scripto, which is fantastic to see. So regardless of your experience level, definitely dive into that community, dive into some of our documentation. I think you'll find it's pretty accessible. And the more people that are looking at this, the better, because the whole point, our mission is that we want to obsolete traditional finance, and we want to do that by allowing developers to build better stuff. So the more developers that are looking at this, the more stuff gets built, the more feedback we get to make sure that new versions of Scripto are really solving the right problems, and we win the world together.
And also the other thing, I mean, the developers, I was going to say that.
Sorry, go on.
Yeah, sorry. You're the CEO. You be quiet, man. Yeah, it's like that's how we are, decentralized. No, one of the things that we hear from developers that's so rewarding is that the learning curve, that time to talent, is so much faster and shorter. And so, like, if you just want to play around and you want to, you're not going to spend 6 months getting proficient in Solidity. You can spend a weekend and you're really up and running, and like that return on your time investment, if you will, and how easy and intuitive it is, because we focus on the DevX so much, has really, paid its dividends. So, and spend 15-20 minutes on it and see for yourself.
Yeah, something to check on is we've got monthly challenges we've been running, basically hackathon challenges, and more than once now we've had people that have read about the challenge, come in, learn Scripto during the month, and then been one of the winners of the challenge. That's happened twice now. So like, that to me is remarkable, that you would actually go from that, from zero to that level of proficiency where you're actually, and this, I mean, this wasn't just us being generous. Like, these are honestly really good components they wrote of like really creative concepts for DeFi, stuff that wasn't being done currently. So
we have a former
awesome.
Billboard #1 music artist who's figured out Scripto, Red Foo from LMFAO. The guy's like a
right. Yeah, I saw that. Yeah,
we didn't pay that. We didn't pay that guy. This was a guy that just like came up to us. He goes, "This is awesome, guys," and like, he's actually a hacker. He's working with this stuff. He's really cool.
Perfect. But okay, guys, thanks a lot, everyone who's watching. Go check out developers.radixlt.com and get started. And hope to hear more from you guys going forward. Thanks a lot, everyone.
Thank you, Ivan. It's wonderful.